Hi there and welcome to this video. If you are sitting the Edexcel Maths A-level exam this summer, then this is the video for you. I have put a series of videos together based on the advanced information issued by the exam board. Here is a list of all the topics that are going to be included on the Maths paper 2, which is on the 14th of June, and I have selected some questions to walk through to give you an overview of what's going to be involved in the paper. The exam board have also issued a series of topic tests which they say best align to the topics that are listed in the advanced information. So I have selected a question from each of the topics on paper 2 and included them in this video in this order. The video is in 2 halves though, so I think it's questions up to question 8 in the first half, and then if you want the questions from vectors question 9 to the trapezium rule, that is in the second video. If I could ask you at some point during the video, if you're finding it useful, do like and subscribe. The more likes just means the more people would get to see it. In the description of the video, there's a download of a PDF of all the questions, so you could have a go at the questions before you watch the video, or I suggest you pause the video when each question comes on and then have a go and see how you would do it before you watch the solution. Or you can look in the description, there are chapters, so you could go directly to a particular question or topic that you wanted to look at. Do leave comments below because I've probably made some mistakes along the way, so you're welcome to leave comments as well. So let's get started then. This is my question 1, even though it says question 3, it's just because these questions are taken from the topic test, so it's my question 1. It says if m and n are irrational numbers with m not equal to n, then when we multiply them together it is also irrational. Disprove this by a counterexample. So all we need to do is find 2 numbers that are irrational, times them together and show that the answer is not irrational, i.e. it is rational. So what are irrational numbers? They are numbers that can't be expressed as p over q, where p and q are integers. So an irrational number cannot be expressed as a fraction in its simplest form. So irrational numbers are things like pi, e and surds, and it's surds that I'm going to use to disprove and use as my counterexample. So if I say that m is equal to root 2 and n is equal to root 8, then when we multiply them together, you're going to get root 2 times root 8, which is root 16, which is plus or minus 4, which is rational. So that's just one example. You could have had many other examples where you're timesing them together and you're getting a rational number. So we've done part A. Part B, sketch the graph of y equals mod x and then plus 3. So do we know what mod x means? It just means that when anything is between those 2 mod lines, then if it is negative, you read it as the positive. So mod of 3, well, there's no negatives there, it's just 3, but the mod of minus 3, it just means what's the sheer size. Doesn't matter that it's 3 below 0. How far is it below 0? It's just going to be 3, so it's the absolute value. So when you are plotting mod graphs, let's just have a look at the plot of mod x. So remember, between the lines must be read as positive. So when x is positive, then the line y equals x is just going to be fine. But when x is here negative, say minus 1, it's being read as plus 1. So minus 1 goes in, but then it's read as plus 1. And then if y equals plus 1 as well, you're just going to get that reflection there. So you're going to get all these sort of V-type graphs. Now, what about mod x plus 3? When we add 3, just using our transformations of graphs, that's going to shift the mod x graph up by 3 places in the y direction. So the graph of mod x plus 3 is going to be that V shape there, just going through at 3. Okay, so that's part 1 for B. What about part 2. Explain why the graph we've just drawn is going to be always above or equal to when we've added 3 and taken the mod. So what does that graph look like? If we think of just the graph x plus 3 without the mod, that has just got gradient 1, y-intercept at 3. So it's just going to come down with gradient 1. Now when it hits the y-axis there, it's not gone negative, so it can continue on. It's only going to be a problem when it gets to the x-axis, and that's where it'll be reflected. So if we put those graphs on the same graph as we did before with part 1, then the graphs are going to be the same here, but when it gets to the y-axis, the x plus 3 and then take the mod is going to continue down, and then it's going to go parallel to that other one and reflect up. So we can see that mod x plus 3 is going to equal mod x plus 3 when it's inside for x bigger or equal to 0, but mod x plus 3 is going to be greater than mod x plus 3 for x less than 0, and we've shown the 2 on the graph. So this red one is x plus 3 and then the modulus. So here's the next question, question 2, and it's the sum of a series from 1 to 16, so first 16 terms of 3 plus 5r plus 2 to the r. Now this first section is an arithmetic progression or arithmetic sequence, and the second part is geometric. So we're going to have two things going on. If we separate them out and do it as the sum of the arithmetic series, and then do it as the sum of the geometric, and we've got to show that we're getting to this value here. So you get on the formula sheet the sum formulae for both of these types of series. So for the arithmetic, then Sn is going to be n over 2 2a plus n minus 1d, and then the geometric is going to be a into 1 minus r to the n all over 1 minus r. So for the arithmetic, then a is going to be, well, what's the first term? When r is 1, 5 times 1 is 5, add 3 is 8. Your d is equal to 5. If you've got 3 plus 5r, it's just really the 5 times table all shifted up 3 places. So it's going to start at 8 but go up in 5s, and n is 16. For the geometric, we've got a is equal to, well, when r is 1, 2 to the 1 is 2. R is equal to, now if you just write a few of them out, 2 to the 1 is 2, and then when r is 2 it'll be 4, 2 squared. When r is 3 it'll be 2 cubed. So what is the common ratio? It's going up by a times by 2, and again n is equal to 16. So let's put those numbers in. N is 16, 16 divided by 2 is going to give you 8 on the front. Double A is 16 plus n minus 1, 15 times 5, our common difference, plus a is 2, 1 minus 2 to the 16, all over 1 minus 2. And if you do that, put all those numbers in your calculator, you do get the 131,798. Okay, part 2, we've got an iterative formula because we're being told how to get to the next term along and what we do to the previous term. And it's always going to give us a starting term. We're going to start with u1 being 2/3. So if u1 is 2/3, u2 will be 1 over u1. Well, what happens when you do 1 divided by 2/3? 1 divided by a fraction, when you're dividing by a fraction, you do a times sum and turn it upside down. So that would be 1 times 3 over 2. So when you're going to just do 1 over that fraction, the sequence is going to go 2/3. The next one along is going to be 3 over 2, and then we'd be turning that one upside down. So it's just going to go 2/3, 3 over 2. So you can see it's going to be the same two terms just repeated, and it's asking us for the first 100 terms. So we just need 50 lots of this. So it's going to be 50 times 2/3 plus 3 over 2. So if we do 2/3 plus 3 over 2, that's going to give you 13 over 6. So it's 50 times 13 over 6. We do that on our calculator, that is 325 over 3, which is 108 and 1/3. So the next question is about functions. We're given a function, we've got to try and find the inverse function when x is equal to 7. So how do we find inverse functions? Inverse functions are just what you do to unravel. So say I had the function y equals 2x, the inverse function would be half x. It's just the opposite of what you would do. So here, because it's quite a complicated function, if we let y equal the given function, and what we do is then try and rearrange that to make the x the subject. And this rearranging is the process that you would go through to reverse the function. So if I cross multiply and take that denominator up, you'd get yx minus 2y is equal to 3x minus 7. Now the thing I want to make the subject is appearing twice. I need to get the x's all on one side. So take that 3x to the side, the minus 2y to that side. So yx minus 3x is equal to 2y minus 7. Now take out x as a common factor. And then I've gone from x appearing twice to now just having it once. And then x is equal to 2y minus 7 and divide by the y minus 3, cross multiply and take that down. Then this is the rearrangement and the unraveling, the reverse process of getting back to x. So functions and their inverses are both functions in their own right, and when you have a function you always write x as an input value. So the inverse function is going to be this same function I've got here, but you've just got to rewrite the y as x because you must have input values as x, not y. So it's just going to be exactly the same, but just write it as x instead of y. And then it's asking us to find the value of it when x is 7. So 2 times 7 is 14, take away 7, which will be 7, and then 7 minus 3 is 4, so that's 1 3/4 or 7 over 4. So that's part A. Part B, when we go through the function twice, what is the expression we get out? So you can see the given function says 3 times the input take 7 divided by the input take 2. Now when you've been through the function once, you get all of this as your output, so that now needs to be my new input when I go through it again. So f of x is going to be, well, what does the function tell me? 3 times the input, and the input is now going to be what I've just got when I've been through the function once. So it's going to be x minus 2 there, and then all take away 7. So wherever I'm seeing that input value, I'm writing the whole of the function because I've been through once. And then on the bottom, I've got the input value x, but I've been through it once, so my output was 3x minus 7 all over x minus 2, and then minus 2. So now I just need to manipulate and tidy this all up to try and get an expression like this. So what does this 3 on the outside mean? You've got to multiply everything on the top by 3. So that will be 9x minus 21 all over x minus 2 minus. Now what I need to do on this top, on this numerator, is just make this 7 have the common denominator. Try and write this fraction as a single fraction. So I need to have an x minus 2 over an x minus 2. So multiply top and bottom by x minus 2. I haven't changed the value of the 7. And then I'm going to have a common denominator. Now I need to divide that by and do the same with this denominator. So it's a 3x minus 7 all over an x minus 2 minus a 2 times x minus 2 over x minus 2. So now I'm going to have a common denominator throughout, and I'm going to have that top numerator divided by that bottom denominator. And what's going to happen is we can tidy up the tops, put it over the common denominator, and you can see the common denominator throughout is an x minus 2. So you're going to have 9x minus 21 minus 7x, and then it's going to be minus 7 times minus 2, so that will be plus 14, all divided by the common denominator there, x minus 2. And I'm going to be dividing by a fraction, but I can times and just turn that one upside down. So it'll be x minus 2, the common denominator on the top, and then you're going to have 3x minus 7 minus multiplying this 2 in, 2x plus 4. Now you can see these are going to cancel, and we're just going to get 9x minus 7x, which will be 2x minus 21 plus 14, which is minus 7, all over 3x minus 2x, which is just x, minus 7 plus 4, which is our minus 3, which agrees with what the question is, but we've just found that a is equal to 2 and b is equal to minus 7. So the next question is a numerical methods question. In particular, you are asked to be able to apply the Newton-Raphson formula. You get the Newton-Raphson formula on the formula sheet. It's how to get to the next approximation of the root is to take the current root and then take away f of xn all over the differential of it. So all we need to do is apply that here by putting x n into the formula. So that's going to be, it's our current root minus 2 times xn all cubed plus xn squared minus 1 all over the differential. So f dash x is just, we need to power down, it's 6x squared plus 2x. So putting xn into that will be 6xn squared plus 2xn. Now all we need to do is make this x, the first term, have the same common denominator. So you'll have x to the n times 6xn squared plus 2xn. And then when we're going to be minusing, then that minus is going to go to all the terms on the top, so they're all going to change sign. Minus 2xn cubed minus xn squared, and then plus 1 all over that common denominator. And then all we need to do is tidy up on the top. You're going to get 6xn cubed minus 2, so that's going to give you the 4xn cubed, which is what we want. The plus 2xn squared minus 1xn squared will be plus xn squared. And then we've got plus 1 on the top all over our 6xn squared plus 2xn. So we've shown that for part A. Using the formula given in part A, with x1 equal to 1, find x2 and x3. So x2, we're just going to substitute 1 into this expression that we've just got in part A. So that will be 4 times 1 cubed, which is 4, plus 1 squared, which is 1, plus 1, all over 6 times 1, 6 plus 2. So that's going to be 6 over 8, which is 3/4. And then x3, when you substitute 3/4 in again, you're going to get 2/3. So you can do that all on your calculator. Part C, explain why for this question the Newton-Raphson method can not be used for x1 equal to 0. If x1 is equal to 0, then the denominator of that fraction part, the 6xn squared plus 2xn, will equal 0. And we cannot divide by 0. So it's not going to home and it's not going to converge, it'll diverge and not be able to find the root. The next question is some parametric differentiation. So we're trying to find dy by dx. So you're given x and y parametrically with our third parameter theta. So what you need to do is do dy by d theta. So y is cosec cubed theta, which is a function of a function. So what you need to do is use the chain rule. Now thinking if I know what theta is, I would be taking the cosec of theta and then cubing. So what you need to do is deal with the second function first. I call that the outside function. So differentiating with respect to the fact that it's cubed, you would power down, leave alone on the inside, take one off, but then you haven't differentiated with respect to the inside function, the thing that would happen second. And if you look on your formula sheet, the differential of cosec is minus cosec theta cot theta. So you just find that on the formula book. Then we need dx by d theta, which is the same again. We've got a function of a function. If we know what theta is, we double it and then take the sign. So you need to differentiate with respect to the outside, which is the thing you do second, the sine theta. Differential of sine is cos 2 theta, so leave alone on the 2 theta. Then differentiate with respect to 2 theta, which would just put a 2 on the front. Now we want dy by dx, which is going to be dy by d theta times d theta by dx. So dy by d theta is minus cosec. Now you can multiply those two cosecs and get cosec cubed theta cot theta, and then times by d theta over dx is just going to be times by upside down of 2 cos 2x, which is just going to put that underneath 2 cos 2 theta. Now for our 3 marks, we found an expression for dy by dx, so you don't need to tidy that up, you can just leave it like that. Part B, find an exact value for the gradient at the point where y equals x, and hence, so we must use what we've just been working with to work out part B, because it says hence. So when y is equal to 8, 8 is equal to, well, what's y? Up here, 8 is equal to cosec cubed theta. So if we cube root, 2 is equal to cosec theta. And what is cosec? It's upside down sine. So if we say a half is equal to sine theta, so theta must be pi by 6. Inverse sine of a half is 30 degrees, which in radians is pi by 6, and that is in the range there from 0 to 90 degrees, pi by 2. So we know at this point on the tangent our theta is going to be pi by 6. Now all you need to do is put that value into your dy by dx, because dy by dx is the gradient function, and that's what we're being asked. What is the gradient at this point? So dy by dx when theta is equal to pi by 6, we've got minus 3 cosec cubed of pi by 6 times cot pi by 6 all over 2 cos. Now double pi by 6 is going to be double a sixth is 2/6, which is pi by 3 third. Why am I writing these wrong? Pi by 3 a third. So cosec cubed is really upside down sine. So that's minus 3 of 1 over sine cubed of 30 times. Now if you know your special triangles, or you can do it on your calculator, if we've got 30 degrees, sine 30 is a half, and so using Pythagoras this is root 3, so tan 30 is equal to 1 over root 3, so cot 30 is root 3, which is the same as cot pi by 6, so that's going to be our root 3, so that's just going to be times by cot 30, which is root 3, all over 2 cos of 60. Well, if this angle here is 30, this is 60, and cos is adjacent over hypotenuse, so cos 60 is a half, and we've got 2 times a half, which on the bottom is just going to be 1. So all we need to do here, the sine cubed of pi by 6, sine 30 is a half, and we cube that, so it is 1 divided by 1 over 8, which will put that 8 on the top, so it's minus 3 times 8 times root 3, all divided by 1, which overall will be minus 24 root 3. So next question, we have been asked for the sum of a series that goes from 2 to infinity of 3/4 to the n cos 180 to the n. So I'd always write a few terms out, just get the feel for what's going on. So when n is equal to 2, you're going to have 3/4 all squared, which is going to be 9 over 16 times cos of 360, because when n is 2, 2 lots of 180. Now from our cos graph, we know that when theta is 360, then the cos of 360 is going to be 1. So the first term, a, is going to be 9 over 16. What about when n is equal to 3? So you're going to get 3 cubed over 4 cubed times cos of 3 lots of 180 is 540. So if we just go another 180 degrees, cos of 540 is minus 1. So this is going to be minus 3 cubed over 4 cubed. And then when n is equal to 4, you're going to have 3 to the 4 over 4 to the 4 cos of 720, which by the time we go another 180 is going to be back to positive. So that's just going to be 3 to the 4 over 4 to the 4. So this sequence is going to go 3 squared, 3 over 4 squared, and then we're going to have 3 over 4 cubed, but the next term is going to be minus, and then we're going to have 3 over 4, the next term will be positive, and then we're going to have minus 3 over 4 to the 5. You can see this cos to the 180n is going to alternate it between positive and negative. So in terms of our sequence, it's going to be a geometric sequence. And how do you get to the next one along? Well, starting with our 9 over 16, how do we get to the next one? We're just going to times it by minus 3/4, and that will send it negative. And then when we times it by another minus 3/4, then you're going to get it positive, and so on. So in terms of our geometric sequence, we're going to have a is our first term, 9 over 16. Our r is going to be minus 3/4, and we're just essentially being asked the sum to infinity. So s to infinity is going to be a over 1 minus r. First term, 9 over 16, and we need to divide that by 1 minus 3/4. So that's equal to 9/16 divided by 1 3/4, and if you put that in your calculator, that's just going to come to 9 out of 28. Let's just do it properly. 9 over 16 divided by 1 3/4 is 7/4. 9 over 16 times 4 over 7. That's going to cancel by 4 by 1, and then you're going to get 9 over 4 times 7 is 28. So here is the differentiation from first principles question. So just to explain a little bit about differentiation from first principles, if you've got a curve, say, and we want to find what the gradient is, so we would maybe take 2 points. This point would be where x is equal to x, and further along x plus h. So this distance here is h. Now, if we read across here, this would be the y value, which would be f of x, and this would be the value of f of x plus h. Now, if you wanted to find the gradient, you'd just do the difference in the y's divided by the difference in the x. So you would be doing f of x plus h minus f of x, the difference in the y's, divided by h. Now that would find you the gradient, but what you are doing when you are trying to differentiate is you're letting h get smaller and smaller so that these points get closer together till when h is 0 and they're on top of each other. And this is called the lim. As h tends towards 0, we are then going to be differentiating because we are finding the gradient at a single point. So that is what you are doing when you're doing first principles. So in this case, we've got that our function is cos theta, so we've just got to apply this lim equation. So we're going to put that f of x is cos theta, or f of theta is going to be the lim as h tends towards 0 of cos of theta plus h minus cos of theta all over h. Then it says to use your addition formula and expand this theta plus h addition angle, and you can find the addition formula in your formula book. So it's going to be the lim as h tends towards 0. The cos one expands to cos theta cos h minus sine theta sine h, and then we've got the minus cos theta on the end all over h. And what you can do now in this numerator, you've got cos thetas here, they can come out as a common factor. So that is the lim. You have to write the lim thing at the front each time. So cos theta, and then it would be cos h minus 1 minus our sine theta sine h all over h. And then we can use these given things that as h tends towards 0, sine h over h tends towards 1, and as cos h minus 1 over h tends towards 0, all as h tends towards 0. Now what we can do is, because both of these terms in the numerator are both divided by h, you can say it's going to be cos theta times the lim as h tends towards 0 of our cos h minus 1 all over h, minus taking the sine theta out times the lim as h tends towards 0 of sine h over h, just splitting those two numerators up and putting the lim in so that we can apply these two facts. That is just going to be cos theta times 0 minus sine theta times 1, which overall is minus sine theta. So there we've shown from first principles what the differential of cos theta is. So in the list from the exam board, you have to be able to do a first order differential equation question, and it does say alongside that that there will be partial fractions included. So here's a question as an example of that type of question. So first of all, we've got to express this fraction in partial fractions. So we're going to get that 5 over our two linear factors is going to be equivalent and identical to our two fractions, a over minus 1 plus b over the 3x plus 2. Go clear of fractions by multiplying throughout by this common denominator. So you just get 5 on the left. Then a would end up with what it's not got because the x minus 1 would cancel, plus b over what it's not got, the x minus 1. And then if we let x equal terms to make the bracket 0, so I would start with the x equaling to 1 to make the simpler bracket 0, so you get into the swing of how it goes. So on the left, x equals 1, you've still got 5, and on the right, the b term will go out, and you'll just have, if x is 1, 3 times 1 plus 2 will be 5a, so that will lead us to say that a is going to be 1. And then if we let x equal what will make the 3x plus 2 bracket 0 is minus 2/3. So again, you'll still have 5 on the left. The a bracket will go out and we'll have minus 2/3 minus a whole 1, which is minus another 3/3. So that will be minus 5/3 b, and then if we just cross multiply, that will tell us that b is going to be minus 3. So being asked to express it as partial fractions, so we've just found a and b, we need to put them back in. 1 over x minus 1 minus 3 all over 3x plus 2. So part B says hence find the integral of what we've just put in partial fractions. So this is going to be the integral of our partial fractions, 1 over x minus 1 minus 3 over 3x plus 2. Now these are both going to integrate to ln's, so we're going to have x minus 1, and then this second term is an example of f dash x over fx, so that's just going to take away the ln of just the denominator, 3x plus 2, and then we can put that all as one log, so it's the ln of x minus 1 over 3x plus 2, and then plus c. Okay, part C, find the particular solution of the differential equation. So we can notice when we're doing differential equations, the strategy is you've got to separate the variables and integrate. So you can see that these terms are going to come down on the other side, the y is going to come down, the dx is going to go up. So we're going to be separating the variables and integrating. It'll be 1 over y dy is equal to the integral of our 5 over the thing we've been dealing with, x minus 1 over 3x plus 2 dx. So integrating both sides, the integral of 1 over y is the ln of y. Integrating on the right, well, that's what we've just been doing, so it's the ln of x minus 1 over 3x plus 2. Now it is plus c. Now c is just a constant, but I can say it's plus the ln of a. Just call my constant another log, so everything's in terms of logs, and then that will be the ln of y is equal to the ln of, just multiplying those two together, a x minus 1 over 3x plus 2. And just have that a times, and then we can use these certain situation that y is equal to 8 when x equals 2, and that will be fed in to give us what a is. So it's going to give you that we've got the ln of 8. Well, what we can do before we do that, the ln on this side is equal to the ln on that side. We can just say that y is equal to a times x minus 1 over 3x plus 2, and then feed in our details that y is equal to 8 when x is equal to 2, and that will allow us to find what a is. So 8 is equal to a when x is 2, 2 minus 1 is going to be 1, and on the bottom when x is 2 you're going to get 6 plus 2, 8. So a is equal to 6 to 4. So all together, the particular solution is going to be that y is equal to 64 times x minus 1 all over 3x plus 2. Thanks for watching and getting to the end of the video. Hopefully you found it helpful. Do keep a lookout for some more in the series. I'll try and post one for paper 1 and the applied paper 2. See you on the next one.